All right, going into Chapter 15, Worksheet B. So looking at numbers 1 and 2 in this video. So number 1, making a deliver, driver can go by route A or B. So for A, driving time is normally distributed with a mean of 88, standard deviation of 20. So for route B, find the driving time is, normally distributed, and they're not telling us the mean on that one. We got the standard deviation of 30. So for part A, find the probability that a delivery to route A takes more than 2 hours. So one thing you got to notice on that is that we are dealing in minutes, and that is an hour. So a little conversion right there. We're going to see that as 120 minutes. This will just be some pretty basic calculator use on part A. So for this one, for part A, we got just basic normal distribution, and we're looking at taking more than 120 minutes. So we just go to distribution, go to normal CDF, and we are going from 120 to infinity, which looks like that. So it said more than 2 hours, so that just means we're going from 120 to the right forever. So that would be our setup. They gave us the mean for route A was 88 minutes, and standard deviation was 20. So there's our setup, and there's our probability. So as always, remember when you round, you got to go 3 sig figs, and the leading zero doesn't count, so 0.0548 would be the most appropriate answer for that. Jumping down to part B, so for route B, the probability that the delivery takes more than 2 hours is 11%, so find the mean. So for these guys, these are the ones where we have to use our little z-score formula. Since we don't know the mean, we can't jump right into that calculator. We got to use a formula to help us out a little bit. So for this one here, remember we got the formula that we've seen in our packet a few times. So you got your x minus the mean over our standard deviation. So for route B here, we're just going to plug in what we know. All right, so we got probability that it's more than 2 hours would be 11%. Remember when we do these guys, our calculator calculates everything from 0 all the way up to whatever number we're using. So if it's more than 2 hours would be 11%, that means on the other side of that is 89%. So, and remember also your z-score formula is based on the standard normal distribution. Standard normal is the one where your mean is always 0 and you have a standard deviation of 1. And so that's what the z-score formula goes with, is that standard normal case, which is what allows us to work with it. So if we go under distribution, and in this case we're going to do our inverse normal of 89%, because remember we always want to, when doing the area, your calculator always wants to know what is the left side of the shaded area. So we got 89% to the left since we had 11% to the right. We're using that standard normal, mean of 0 and standard deviation of 1. So getting our z-score on that, so about 1.23 would probably be enough to round that off. You can go a little deeper since we're not done with this problem yet. So, but anyway, that's the z-score for this. So if we now plug in kind of the numbers that we're working with for this problem, we got our z-score of 1. Let me go a little deeper on those decimals. 65 would probably be enough. So there's our z-score. We're dealing with an x axis value of 2 hours, so 120 minutes. And we're trying to solve for that mean. And we know our standard deviation was 30 minutes for this one. So there's our setup. Now we can solve that little equation for the mean. So if we just multiply that 30 over to the left and then subtract the 120 and divide by -1, we have our mean. So that's what we're going to do for this one. So I'm taking that z-score that I have times 30 minus 120 and divided by -1. It's going to give us our mean, so about 83.2. It's going to be the mean for route B. All right, moving on. So going down to part C. So driver's going to take off at 9. Has to make the delivery before 11. So there's a 2-hour period right there, or 120 minutes. Explain why the driver should travel by route A. So if you kind of look at the answers that we did for part A and B, so for part A, we figured out that taking more than 2 hours, the probability of taking more than 2 hours was just a little over 5%. But on part B, taking more than 2 hours was about 11%. So the probability of us getting there on time is much safer with the answer from part A for route A. So something like that in your own words would be good for part C. So jumping on to part DI. So deliveries to made at the beginning at 9 on 6 consecutive days. So notice on this one we're now dealing with multiple days. So there's our number of trials. So there's where we jump into the binomial features of our calculator, since we're dealing with multiple days going on here. So if route A is traveled, so what's the probability that they arrive before 11 on all 6 days? So let's go to our binomial feature here in our calculator. So if I go into our distribution, now for this one, we're dealing with a specific period of days, 6 days exactly. So it's the binomial PDF. Cumulative is always the one that you use for if it were to say like at most 6 days or at least 6 days, something like that, where we're dealing with a cumulative period of time. But in this case, it's just 6 days exactly. So that's when we use the PDF feature. So we're talking about 6 days. The probability of success that we found earlier on this one. So remember, this is for route A. And they had said that the probability, or we found that the probability that it would take more than 2 hours was the 5.48%. So in this case, we want to know the probability that it's before 2 hours or less than 2 hours. So it's 1 minus the answer that we had, right? Because that 5.5% that we're seeing right here was for more than 2 hours, but this one is now talking about taking less than 2 hours, and so that's why we got to do the 1 minus for this one to get the correct probability in there. And this one says we want this to happen on all 6 days, so that is our x value is 6, and so if we just hit enter on that one, there's our probability, so about 71.3%. So jumping on down to part 2, so if route B is traveled, you get better looking clean sheet of paper here. So if route B is traveled, what's the probability that the driver arrives before 11 on at most 4 days? So notice the change in the wording. That's where it says at most, so now I know I'm going to be dealing with the binomial CDF for that one. So let's kind of consider all the stuff going on with part B here. So if I go back into my distribution and now choose binomial CDF, again we're still dealing with 6 days. So let's look at the probability of getting what we want on this one. We're talking about arriving before 11, which means less than 2 hours. We found up in part B to take more than 2 hours was 11%, so less than 2 hours would be the other 89%. So you could either just put in the 0.89 or you could say 1 minus 0.11. That would give you the same thing. And in this one it says at most 4, so that means we're going all the way up to 4, from 0 to 4. So that's kind of our upper limit right there is 4. Had it said less than 4 days, I would have only gone to 3. But in this case, with the way that it's worded, it is including the 4 because it says at most 4. So that's what we're going to put in for our x value. So now when I hit enter all the way down, it gives us the probability for that one. So about 0.134. So keep with the 3 sig fig idea. That's something you need to be in the habit of doing. Hopefully you are already at this point. All right, moving down to number 2. So here's the other one we're looking at for this worksheet. So bottle of milk, we got a mean volume of 1,010, standard deviation of 28. So bottle contains more than 1050 is overfilled. So we'll come back to that one here in a second. So starting out with part A, so containers randomly selected, what's the probability that it is overfilled? Or in other words, what's the probability that it contains more than 1050? So for this guy, we're just looking at just a very basic calculator normal distribution question here. So we're saying more than 1050, so if I go under distribution, choose normal CDF, So more than 1050 means we're going from 1050 and up. So we're going from there towards infinity. So I'm hitting my, just in case you didn't know, here's the buttons I'm pushing when I do that to get infinity. Is I hit the 1, and then I'm hitting this button right here. The double E comes out as just E on the calculator, which means, that's like scientific notation. It means times 10 to the, and then now I put in 99. It's like the biggest number our calculator can handle. It's like 1 times 10 to the 99th power. So we consider that to be infinity. You know, when in doubt, if I actually just stuck just a really big number in there, I could just hit a bunch of 9s and I would still get the same answer I'm going to get right now. So anyway, the mean they gave us for this problem is 1010 and a standard deviation of 28. So mean was 1010, standard deviation of 28, and there's our probability. So about 7.66%, or you could say 0.0766. So either way, we got 3 sig figs on that. Jumping down to part B. So bottler wants to reduce the probability that is being overfilled all the way down to 2.5%. Sorry, I'm trying to get all that centered on there. So to do this, they make improvements to decrease the standard deviation to something, but we don't know what that is yet, and leaves the mean unchanged. So we still have the mean of 1010. Trying to figure out that new standard deviation based on a 2.5%. So when they leave out the mean and the standard deviation, that's pretty much when we always turn to our z-score formula for standard normal to start working to get some information from that. So keep in mind that this is overfilled is 2.5%. So in terms of a like a normal distribution curve, overfilled, whatever that number is, they want above that to be 2.5%. So they're kind of giving us this area right here. Right, whenever we start putting our stuff into our calculator for z-scores and inverse normal and things like that, we use the area to the left in the calculator. So I'm going to calculate the z-score for this one using our standard normal information. So if I go into distribution and go to inverse normal, in this case the area to the right was 2.5%, so I want the area to the left. So that's what I'm going to put in there for my area. Again, we're just using the standard normal information there to get a z-score. So there's our z-score of 1.96-ish. So for the z-score, so now we can calculate our new standard deviation. So the z-score of 1.96. And now we can use that with our current information. So in this case, we know our x value given up above is the 1050. So that's where it was left off for being overfilled, minus our mean, which is still 1010. And now we can solve that little formula for standard deviation. So anyway, once you solve that, we'll now have that to move forward for part C. So it looks like if we solve that one correctly, looks like our standard deviation came out to be about 20.4. So now going to part C. So now to this new standard deviation that we now know, leaves the mean unchanged. So randomly select it for inspection. If it passes, if the volume is between 95 and 1040, so what's the probability that it passes? So just a basic normal distribution feature on this one again, now that we know our standard deviation is 20.4. So if we go back into our calculator info for this, so I can go back into distribution, just again doing that normal CDF, just looking for a basic probability, and it needs to be between 955 and 1040. So there's our lower and upper bounds. Remember, the mean wasn't changed, it's still 1010. And we got our new standard deviation of 20.4. So there's all the calculator stuff. So that would be our new probability right there. So let me write that one down. We'll probably need that guy moving forward. So we got the 0.926 for that probability. So for part 2, I, given the bottle is not overfilled. So kind of a key word here that links us back to our probability stuff is that word given. So we have a conditional case. So remember how we've done given problems in the past. We do something like A given B. So remember when we do that, we always do the given on bottom, and we always do the A and B on top. So keep that in mind. That's got to lead us into our setup here for this question. So given that it's not overfilled, so that's what's going to go on bottom of our setup is the probability that it's not overfilled, which is our given, which is our given information. So remember, that's something we were kind of told up above right here. We were told that if it's overfilled, it was 2.5%, which means for this one, if it's not overfilled, it's just the complement to that. So 1 minus 2.5% would be that probability. So you can we'll just write it all out, I guess. Obviously, if you just wanted to put 97.5% down there, we could do that as well. So anyway, that's our denominator. That's our given probability that it's not overfilled. So now we're looking at the top where it says the probability that it passes. Remember, the way that we would read this then is the probability that it passes inspection and is not overfilled. And so that's what we're looking at for the numerator. Also remember what we were told up above in the initial part of this problem, that if it's overfilled, that means it was above 1050. So that's what we were told. So if I kind of put all the information together on this one, we're saying the probability that it passes inspection, which is what we just did right here, and is not overfilled. So it has to be between those numbers and less than 1050, which this probability is already less than 1050, so we're already taken care of that part of it. So this probability is the probability that it passes inspection and is less than 1050. So that's what we have right here with the 0.926. So that would be our setup for that one. So punching that one into the calculator, so you got your 0.926 over your 0.975. And so that should be our answer to that one. Looks like for this one, to do 3 sig figs accurately, we need to say 0.950. So throw that 0 in there, so you got 3 sig figs. The ending 0 does count as a sig fig, so put that one in there. All right, moving on. Part D, last question. So sample of 100 bottles is randomly selected, so probability that 95 or more pass inspection. So one thing to keep in mind is we are now dealing with a binomial situation here because I have multiple trials. This is no longer one scenario. It's now for 100 scenarios. And so this is where the binomial features come into play. So we got that 100 bottles. That's our number of trials. And looking for the probability that 95 or more pass inspection. So one thing you got to keep in mind here is that 95 is inclusive with that statement. So they're talking about 95 and above. Well, remember what we always put into our calculator is everything to the left on this. When we do the binomial CDF feature, the calculator wants everything up to a certain point. And so since this 95 is included with the right side of the probability or the right side of the curve, we want everything that led up to that. So we're going to go basically from 0 to 94 to do our setup. So for this one right here, get rid of that. So you got your 100 trials. So let me go into distribution, binomial CDF. Since we're dealing with a group of answers, it didn't say 95, it said 95 or more, so it's cumulative. So binomial CDF. So we got 100 bottles. And in this case, remember the probability of success we found earlier on. So this one's talking about passing inspection, and we figured that probability for passing inspection was the 0.926. So that's our probability that's going in. And in this case, so remember what we just talked about. This was 95 or more, so the 95 was included in this upper area of the graph. So we need everything below that. So we're going from 0 to 94. to get that part of the answer. So keep in mind to answer the question appropriately, what we just figured out was the complement to this. So we just figured out that everything below this is this probability. So I have to do 1 minus that in order to get what the question is asking me for, which is the right side of the information. And so that's where we should get 24.2% on that one. So keep in mind, one thing that typically helps is, if you ever give yourself a little drawing, that just sort of helps you keep in mind what you have and what you're working with. Since the calculator typically, in most cases, works with everything to the left side, it kind of helps to identify what you have and what you need to answer the question appropriately. So we were looking for that 95 or more, which was this area right here. But the way the calculator works with like a binomial CDF or inverse normal and things like that is your calculator always works with this area to the left of your value. So for these problems, it kind of helped me to sort of view everything in light of this drawing. And so when I got my probability of the 0.757 whatever, this is what the calculator gave me when I did my binomial CDF. So I then understand here's what the question is really asking me for based on that wording right there. And so that's how I knew to subtract this from 1 in order to get this answer that they're looking for.